Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. The objective of this video lecture is to introduce Lagrange's interpolation formula, its derivation, and the SV University April 2025 example and inverse interpolation. It must be used when the arguments are at equal or unequal intervals. The function type is y is equal to f of x is assigned to be an nth degree polynomial. The advantage of Lagrange's formula is there is no need to construct a difference table, but the only limitation is calculations can be more complex and time consuming compared to Newton divided difference formula. Let x0, y0, x1, y1, so on xn, yn be n plus 1 paired values. We approximate f of x as an nth degree polynomial. F of x is equal to a0 x minus x1 x minus x2 so on x minus xn plus a1 x minus x0 x minus x2 so on x minus xn and the last term an into x minus x0 x minus x1 and x minus xn minus 1. Our objective is to identify the coefficients a0, a1 and a1, an and to find the derive Lagrange's interpolation formula. To find the coefficient, first coefficient a0, put x is equal to x0. Since all other terms contain x minus x0, from a1 to an, they became 0. So, y0 is equal to a0 into x0 minus x1, x0 minus x2, so on x0 minus xn. This implies the coefficient a0 is equal to y0 divided by the multiples of this term x minus x0, x minus x2, x minus xn, so on. So this is equal to pi j not equal to 0, xi x0 minus xj. Similarly, the second coefficient a1 is equal to y1 divided by pi j not equal to 0, x1 minus xj. Like that, the other coefficients can be estimated. Substituting all contains a I back into the polynomial, the Lagrange's interpolation formula can be given by f of x is equal to summation I is equal to 0 to n li of x into yi, where li is the Lagrange fundamental polynomial, that is given by lix is equal to x minus x0, x minus x1. We need to skip x minus xi here. If it is 0, we need to skip the x minus x0. x1, we need to skip x minus x1. Like that, we need to skip the term divided by xi minus x0, xi minus x1. Here also, we need to skip xi minus xi, so on xi minus xn. Let us discuss an example. Estimate y is equal to f of x when x is equal to 10 by using Lagrange's interpolation formula for the following data. Here we are given 6 arguments, x0 to x5 and y0 to y5. The Lagrange's interpolation formula is given by f of x is equal to x minus x1, x minus x2, so on x minus x5. Here we skipped x0 term, x0 minus x1, x0 minus x2, so on x0 minus x5 into y0. Here we skip x1 term, x1 minus x0, so y1. Here there is y2, y3, y4, y5 terms. We skipping here x1 we skipped, here, x naught here, x1 here, like that. We are skipping this term. Here we skipped x naught, here y naught, here y2, y3, y4 and y5 terms. So this is the Lagrange's interpolation formula. Substitute the values. X naught is equal to 5, 6, 9, 13, 19, 28 and y naught values. We get this term. So on simplification, f of 10 is equal to 25.457. This is approximately when x is equal to 10, the value of y is equal to 25.457. Let us discuss the SV University April 2025 examination problem. Find the form of f of x using Lagrange's formula for the data. X values are 0, 1, 2, 5 and y values are 2, 3, 12, 147. Here these values are not equidistant. So we can use Lagrange's interpolation formula. Li of x is equal to, skipping x minus xi, xi minus xi. We find L naught x, L1x, so on. This L naught x is equal to x minus x1, x minus x2, x minus x5. Here x naught minus x1, x naught minus x2, x naught minus x3. Like that, L1 of x, L2 of x and L3 of x. We need to multiply these L0x, L1x, L2x, L3x with the corresponding y0, y1, y2 and y3. So this is the summing the terms f of x is equal to this is y0 is equal to 2, y1 is equal to 3, y2 is equal to 12, y3 is equal to 147. And on simplification, after expanding and collecting like terms, the polynomial simplifies to f of x is equal to x cube plus x square plus x plus 2. The inverse interpolation using Lagrange's formula. Sometimes we need to estimate the value of x for the given values of y. So in that situations, we use inverse interpolation. The formula for inverse interpolation can be obtained from Lagrange's interpolation formula by interchanging the values x and y. In place of x, we use y. In place of y, we use x. Thus, for n plus 1 arguments x0, x1, x2, so on xn, the suitable inverse interpolation formula for estimating the unknown value of x corresponding to the known values of y. Simply, we swap the roles of x and y in the formula. The inverse formula is given by x is equal to, instead of y, x is equal to y minus y1 into y minus y2 divided by y minus y1, y minus y2 into x0 plus y minus y0, y minus y2, so on, divided by y1 minus y0, y1 minus y2 into so on into x1 plus so on. For this is the interpolation formula. X is equal to, we need to multiply with x0, x1, x2, so on, xn. The previous term is y minus yn minus 1. Estimate the value of x when y is equal to 21 from the following data. Here we are given x0, x1, x2, x3 and y0, y1, y2 and y3. This is the interpolation Lagrange's inverse Lagrange's formula. Y minus y1, y minus y2, y minus y3. We skip x0 here. y0 minus y1, y0 minus y2, y0 minus y3 into x0 here into x1 into x3 into x2 into x3. Simply substituting the values of x and y given values, the final answer is x is equal to 49.6618. This is approximately equal to 50. Another example, the given 5, 12, 6, 13, 9, 14, 11, 16. Find x when y is equal to 15. Here x is equal to 15 minus, here we are given y is equal to 15. 15 minus 13, this is 13. 15 minus 14, 15 minus 16, and 12 minus 13, this is 12. 12 minus 13, 12 minus 14, 12 minus 16, so on. The simplified, after simplification, 11.5 is the answer. Thank you.